This is a short lesson on understanding computer networks. The lesson outcome and plan for this are essentially that we are going to analyze a courier scenario to comprehend the workings of computer networks and to understand a little bit about the various devices that are used. The internet is an excellent example of a very giant network of networks. And in this session, we're going to explore the various elements that are used to build it and to look at alternative pathways. When individuals go to browse the web, as we know it, the web is actually an application on the internet, and we use it to get information that is stored at various elements. And the network has many routes that can get to a specific site, and there are all kinds of different elements and links with different speeds. And so the internet as we know it, or the World Wide Web, which is the application, is using multiple routes and multiple network elements to get there. The elements are connected by different network media and connectors. One such media is the coaxial cable used by the cable industry, the twisted pair cable that is used by DSL networks such as Bell Canada here in Canada, and fiber optic cables, which are used largely over longer distances and that provide throughputs over 1 gigabits per second. The network equipment comprises of multiple elements. The one that we're most common with as users is the desktop computer or a laptop, which has a NIC card, a network interface card, which allows us to connect to a switch. The switch allows multiple types of devices to connect to it, such as an IP phone, a video phone, PCs, servers, printers, and then these switches are connected to routers, which essentially route packets on a hop-by-hop basis. And their job really is to make sure that the packets eventually get to the destination. We also have firewalls, which provide security and provides us with intrusion protection from unwanted elements outside the network trying to connect to our network. And then there is always the modem, whether it's provided by a DSL provider or by a cable provider, which essentially connects us to the service provider. Now let's take a look at the nomenclature as we talk about kilobytes, megabytes, and gigabytes. Kilobytes are 1,000 bytes. Typically, a small email is about 2 kilobytes, and a link in kilobits per second would be good enough for transferring small amounts of data or a few pages of text. Megabytes are 1,000 kilobytes, and typically files that have audio such as MP3 would be around would need a speed of about a megabyte per minute. So you're really looking at megabits per second for links that use a lot of audio data and for high quality pictures. A gigabyte is a billion bytes, which is 1,000 megabytes. And a good example of gigabytes, as you would have come across, is in your RAM for your computer. A typical computer, a laptop, would have 8 gigabytes or 16 gigabytes of RAM, which is random access memory. A DVD has 4.7 gigabytes of memory. So a link that has is rated in gigabits per second would be used mostly for connections to YouTube, getting videos and such. The message here really is that the type of link that you need is dependent on the application. For applications that don't have a lot of data on it, kilobits per second is just as good as a gigabit per second. In fact, the only difference here is that you're paying a little bit more for a link that you don't really use. Now let's look at how computer networks work by looking at a courier scenario. Let's say that you have a package that's to be picked up from Professor Jones at Humber College, which is at Highway 27 in Finch, here in Toronto, to Professor Ali here at Centennial College at Progress Avenue as quickly as possible. What you would probably end up doing is take a look at Google Maps, listen to the news to see what type of traffic is there in that area, and what would be the best way of getting here. Some of the things that you're really looking at here is the source and destination, which is in this case Humber College. Source, destination is Centennial College. And then you'd be looking at what routes are available. There you could take Highway 407, you could take the 401, you could take Finch, and a number of other alternatives are out there. And your decision as to which specific highway or road you take will be determined by the number of stop signs that are there, the amount of traffic that's there, any information on any specific accidents that might have occurred. So if we take the scenario that we just looked at and translate that to how a computer network works, you have various devices that are to the left, such as a video phone or a video camera, or PCs that are trying to connect to the internet for sending and receiving data. They're all connected to a switch, and then the switch is connected to a router, which then has two paths that go out to the internet. And depending on whether the main path is available or not, the packets would go over the alternate path. So there are multiple paths available. The choice to select the alternate path would be dependent on whether the main path is available. So in this case, if router 2 failed for whatever reason, then the packets would transverse over the alternate path to get to the internet. So very similar to our scenario when we looked at transferring or couriering the package from Humber College to Progress Avenue. So to sum up what we will learn here, with that essentially every packet has to have a source and destination address that would allow the packet to be routed to its correct destination. Routers select the best path depending on whether the route is available or not, and then the type of link that you would use or the type of connections that you would use is really dependent on the amount of traffic that you expect to transfer. So it's dependent on the application, as you would expect in a highway where the number of lanes are determined by the amount of traffic that goes through.